Hey everybody, so I wanted to spend a whole video dealing with the binary search. It deserves its own video. It's the most well complicated search that we're going to talk about. So there's quite a bit of code and a little bit of theory behind that. So I figured we'd start off with the theory, and that this is what a binary search is. This is how it works. Uh, so if you get into it, the first requirement of a binary search is that requirement number one is that it requires an array in ascending order. In our last video, we did arrays in descending order, so I went ahead and changed our selection sort to be in ascending order. So I made that change and in between videos, and took the same array, run a sort on it, and now you can see the output down below is in ascending order, so that my selection sort is working. So I have fulfilled requirement number one. And if you see here, 1, 2, 3, 4, 5, 6, 7 elements. So if you look at how this works, then once you've met the requirement, is that it starts with the element in the middle of the array. So in this case, instead of starting in position 0, which the sequential search started at 0, the binary search starts in the middle. So here the middle would be 24. So it starts in the middle. If the element that you're looking for is found, then the search is over. Otherwise, if the value in the middle is greater or less than, so you're basically, okay, is this your element? Yes or no? Well, if it's not, is it less than or is it greater than? If it's less than, then we're going to search these three elements. If it's less than, we search these three. If it's greater than, we'll search these three. So that's what this basically says. If it's greater than the desired value, search the first half. Otherwise, search the last half and repeat as needed. So now, let's just say it's less than. We know we're searching these three elements, and you're going to pick the middle element. And is this your element? Yes or no? Is it greater than or less than? And repeat. So on average, the number of iterations through a loop will be less with a binary search. Therefore, it is more efficient on average than a sequential search. So that's why a binary search is the preferred when comparing just the two. However, that's the pros. The cons would be that it's more complex. The algorithm is more complex. So I'll go ahead and start writing some of the code for our binary search. And I'm going to write another method so we can perform this search as many times as we like. We're going to accept an array. I'll just call our array nums and the value that we're looking for. And this is going to return a number depending on if it was found. So if it was found, it's going to return the position in the array that it was found at, or a -1 if it was not found. So if our number was 23, this method would return position 2, because it would be 0, 1, 2. If it wasn't found, if we're looking for 99, that's not in there, this method will return a -1. So again, this is such a common method to search because it's one of the ones that we always study in the academic world. So if you do a simple Google search for a Java binary search, you're going to find everyone's different implementations of a binary search, naming their variables differently, but it's all the same logic as up above. So this is just one way to implement it. There might be others. As long as it follows those steps, then we can call it a binary search. and I'll try and be thorough on my documentation here. This is the first array element. Last array element. Midpoint of search. And position of search value. And we're going to create a flag for if it was found or not. Boolean variable called found. This is our flag. Let's go ahead and set some initials values. Set the initial. So the first is always going to be 0, the first element. The last is always going to be the length of the array minus 1. The position is equal to, we're going to start it at -1. We'll change that shortly. And found is false. It is not found initially. Now we're going to search for the value. So while it's not found and first is less than or equal to the last. Middle is assigned to the first plus the last divided by 2. So this is calculating the midpoint. Now we need to see if that is the value. If nums sub middle equals the value, then we're going to set found to true and set the position equal to where it was found, which was the middle. Otherwise, we're going to see, was it greater than or lower than that position? So again, this says if the value is in the lower half. Then we set the last equals middle minus 1. Otherwise, if the value is in upper half. So now all we need to do is return the position. And again, this is basically return the position of the item or -1 if it wasn't found. Okay, and that is the logic for our binary search. So here is our numbers. We went ahead and sorted them and demonstrated that they are now sorted. So we meet the first requirement. Let's go ahead and write, let's call our method then. Let's call our binary search. Let's make an int to store the value of the position or -1 equals binary search. We need to pass it our nums and the value we're searching for. So numbers is our array. Let's just say we're looking for 24. Now 24 should be found inside of position 0, 1, 2, 3, 4, 5. So result should hold 5. And we'll go ahead and write a simple if. If result equals -1, we'll say result was not found, else result was found at, oh, I realized, I just stopped myself here for a second. I realized we just want to say element was not found because I'm just plugging in the value. So you could even say 24, was not found, but I'm just going to leave it at a value was not found. And then for the else, I will say value was found at position plus result. Okay, so again, 24, we got 0, 1, 2, 3, 4, 5 should be the printout. And it says it was found in position 3, 0, 1. That's clearly not what I was expecting, but let's try a value here. Let's try 28 because that should not be found. So that was not found. I'm kind of looking at the algorithm here. We're returning position. Position is equal to middle, at which point middle is a calculation. At which point this really is not the position. So this is really returning whether it was found or not. If I try a couple different values, let's just say 5, it's not going to return. See, that says position 1. Say 1 now. See, 1 is saying position 0, 23. So it's returning based on the math that inside of our algorithm. Now that is correct. That is position 2, but it's not the actual. Again, if I just were to say 5, 5 would be, let's say that's position 1, and then 1, position 0. So it's not the position. It's just saying whether it was found or not based on the math. So really we can say whether it was not found or it was found. One last thing is I did want to introduce import java.util. The arrays class, and the arrays class has these methods actually built into it. So realize, it's a good experience to go through and write these, but they did get included in the Java API at some point. So we can simply say arrays dot binary search and pass it our values just as we did right here, and this would work the same way. Arrays dot sort, same thing. So I just wanted to demonstrate the arrays class in that you don't even necessarily have to write your own logic. It is actually built in. So just wanted to introduce that. Thanks for following along.